Sorry. Okay, two things you need to know about the rows is that this first number here, A, that tells you the length. So A gives you the radius, I should say. The furthest radius. So if you wanted to go out to the fourth ring, you want to start it with a 4. Now, N is tricky. If you pick an even number, then the number of petals double. So for example, let's see how many petals we have. 1, 2, 3, 4, 5, 6, 7, 8. So that meant that this equation, N equaled 4. That's how they were able to get 8 petals. So if you pick an even number to go in front of theta, it's going to double the amount of petals. But if it's an odd number, it just stays the same. So this has just 3 petals. So this was N equals 3. Now, when you're typing this in your calculator, you can just do the first 5 and I'll give you the rest. You want to make sure you're putting it in the same parentheses. So you should type in R equals 3 sine and then 2 times pi over 6. Make sure that it's in the same parentheses. If you put 2 in the parentheses by itself, it's not going to give you the right answer. So go ahead and take a minute, fill in the first 5, and then you can get the rest. I'll fill in the rest for you. What did I do with my... Just a reminder, please bring in your pre-calc books. I'll try to remember to send out a message in Canvas. Don't bring them tomorrow, though, because I'm not here tomorrow. Okay. So a couple things to note. See how A is 3, and 3 is the furthest radius that we're going to reach. We're not going to go past the third ring because we started with a 3. Now, N in this example is 2. And because 2 is even, this graph had 4 petals. All right, go ahead and graph it out. Okay, any questions about this particular graph? Okay. All right. So I don't recommend you do anything too ambitious like n equals 8. Like 16 petals is too much because you want to make sure it's something that will fit on your graph and that it's actually neat. That it's neat. Let me look at the different graphs. The radius. All right, so now let's go ahead and look at our second one. So this one is a little tricky. So go ahead and fill in our values. So this one is going to reach R equals 4. It's going to be your longest petal. Now, is N even or odd? What's the number in front of N? Is odd. N equals 3. So that means that we're just going to have 3 petals. We don't double it. So take a moment and just type in the first 4. Then we can finish out the rest together. So again, make sure when you're typing it in, you do 4 cosine, and then in one parentheses, 3 times pi over 6. They have to be together. And you can kind of see why this one is a little tricky, because using the points on the unit circle is not enough to get the full graph. So we'll talk about what we have to do in that case. Okay, so when we look here, we can kind of zoom in. You can kind of see that we have half of a petal. This is half of a petal. So to make it symmetrical, I need to add this point right here. But we need to figure out what is the angle of that point. So in order to do that, I'm going to add more angles to the graph. So I'm actually going to split this up into smaller slices. Okay. When I split this up, let's see how many slices we have. This is 1, 2, 3, 4, 5, 6, 7. Okay. So everyone see that this, well, let me keep counting. 8, this would be 9, 10, 11, and 12. So the number of slices that I have in the first two quadrant, that's my denominator. All right. And where did I put this point that I needed? On what line? That was the 7th line. So this would be 7 pi over 12. So this point that I'm trying to add to my table is 7 pi over 12. So you have to make sure you may need to add angles that are not originally listed on your grid. Does that make sense? Because it has to be symmetrical. And every petal, if you're doing a rose, you need at least 3 pins per petal. So if you're doing it and you notice just doing the angles on the grid is not giving you the full petal, then you're going to need to figure out where the angles are for the other points, because they have to be in your table. So this is 7 pi over 12. All right, let me go here. Go ahead and type that in the calculator. I'm gonna go ahead and do the same thing for the bottom half. We're still counting over 12. So this will be 13, 14, 17, 18, 19, 20, 21, 22, 23. And then we end at 24. 24 over 12 is 2. So we need to add 7 pi over 12 to our table. When you type in 7 pi over 12, so you're going to type in 4 cosine 3 times 7 pi over 12. Go ahead and type that in. You should get 2.8. Now I have a full petal. Has to be a full petal. Now, when I go down here, I'm also missing a point on this line, which would be what? 17 pi over what? Over 12. So we need to add 17 pi over 12 to our table too. Any place that you put a pin needs to be in the table. So when you type that in, you're also going to get 2.8. So now I have 2 complete petals. All right, now for this third one though, I only have 1 point. So I need to add in 2. I need a point here and a point here. So that was going to be pi over 12 and 23 pi over 12. And those will all be 2.8. And now we have the complete graph. So you have to add angles as needed. Every pen needs to have a point on the table. Okay. So let's start talking about the project. So let's look at the rubric or at the directions, okay? Now the rubric is different depending upon how many people are in your group. So first thing first, this is a 30-point project. The due date is Friday, May 15th. If you turn it in after the following Monday, which would be the 18th, you automatically lose your chance to earn extra credit. So no extra credit after that date. And then every single day after that, I'm taking off 10%. Now, this project theoretically in the past, I should say historically in the past, has taken between 3 and 4 days. And you're going to start the designing process tomorrow, and then Friday you're going to start building your graph. You really should be done, I mean, if you're actually working on it for the full class period, no later than next Wednesday. Because the hardest part is just creating the tables, which is what you're going to do tomorrow, okay? So we've learned about all the polars and their graphs. So now you're going to complete a polar project during class with the help of one partner. Now I did modify this, so I have individual, pairs, and groups of 3s. So this is going to allow you to demonstrate what you have learned, show your creative side, and round out your semester grade. This is your chance to bring up your grade before going into finals. Okay. You have to do a minimum of 4 polar graphs on your board. Each one has to be done in a different color. So I have plenty of string in all different colors, okay? You have to use different colors for every graph so I can tell it on the board. All right, you can have multiple of each type if you wish. The harder ones are worth more points. Groups or people, I should say everybody, because I got some people working alone. You have to give a table of values for each graph on a separate sheet of paper and attach it to the back of your board. All of your angles have to be in radians. Make sure your tables are neat, organized, and color-coded so that I can easily identify what type correlates to each graph. Make sure everyone's name is on the back of the project. So Friday, everyone is going to get their foam board. Then you have to determine what color construction paper you want to be the background. I'm going to give you 2 options for a polar graph, strings, pen, and then you'll have one in the middle. That's going to help you keep it all together. All right, so now let's go